We're looking at practice problems for this week, 2.8 through 2.11. So starting in lesson 8, here we go. Relationship between distance in yards, y. So yards are over here in y. And the same distance in miles, m, on this side over here, is described by this equation. So this is saying to get what y equals, we take m and we multiply it by 1,760. So if that's our path to getting the answer, we just multiply the numbers on the left by that. So 1 times that number is 1,760. 5 times that number, you can multiply it. 0, 30, carry the 3, 35, plus 3 is 38, carry the 3, 5 and 3 is 8,800. So this would be 8,800. If we wanted to work back the other direction, then we would divide by that constant of proportionality. So we would come back with division. So we're going to divide by 1,760. Luckily, that is going into it twice, so that comes out to be 2 when we divide 3,520 by it. And this one right here is going to go into it a nice round 10 times because all they did was add a 0 onto it. So table complete. Check on filling out the table. So that's part A. Part B, is there a proportional relationship between a measurement in yards and a measurement in miles for the same distance? And we're going to say yes, there is. So yes. Explain why or why not. Yes, there is a constant of proportionality. So the constant is 1,760. You can write that down. It works for every pair that's in our table. We used it to fill out our table. So that's how we know it's a proportional relationship. That's number 1. Number 2, decide whether or not each one is a proportional relationship or not. We should have done this the other day in class. Okay, this one's not because there's a minus sign. This one is good because you're just multiplying one variable to get another. And C is okay. The variable's on the numerator, not the denominator. So this one's alright. Just dividing a variable by a number to get another variable. That's what a proportional relationship does, like you see in the table. And then finally, part D here, 12s squared. A big fat no there because you can't have an exponent in a proportional relationship. And I think we have enough time. We can knock out this bottom one as well. It says that y is found by taking 5 halves and multiplying by x. So if we plug in all of the x's in that place of where the x is, we put 2 there and we do 5 halves times 2, and we put a 3 there and we do 5 halves times 3, and then we put a 6 there and we do 5 halves times, not 5, 6, 5 halves. We do 5 halves times 6. We do all of those multiplications. We should be able to get the y values that are next door. So this turns out to be 5 halves times 2 is 5. And then 5 halves times 3 is 15 over 2, or 7.5. And then this one is 30 over 2, which is 15. So we multiply all those out. We fill out the table. And then it says, is it a proportional relationship? And we're going to say yes. We could have told that from just looking at the equation. The equation looks like a proportional relationship because there's no plus, there's no, so explain why or why not. We could say 5 halves is the constant. That's why it's a proportional relationship, because it has a constant of proportionality of 5 over 2, and it works for every pair. This one over here has a plus sign in it, so we're going to go ahead and say no. There is a plus in the equation, so that's a problem. That's why it can't be proportional. But we still have to work it out and find out all of the y values, so let's do that real quick. Y equals 3.2 times x, which is 1, plus 5. That's going to be 3.2 plus 5, which is 8.2 for this one. And then the next one puts a 2 there, so we're going to double the 3.2 and add 5. That's going to get 6.4 plus 5, which is 11.4. And then the last one is times 4, so 12.8 plus 5.